Awesome.
Do we know if Dennis is coming today?
I thought he said he was going to come.
I'm only asking because I wasn't present at the last working group meeting.
Can open. Hang on. It does feel like forever, doesn't it, Christina?
Yeah, it was April, so it was good 4 months ago.
Yeah.
I'm
that
happy.
was the KeyTOS presentation. I don't think there's any actions in here.
No, there are no actions, but one thing that was flagged as an upcoming event was the IWN conference. Elisa, you were there. Do you want to just maybe give us a bit of an update how that went?
That really, really well. And I'll pop into the chat. We've actually published all of the individual conference videos on our website as well. So I'll pop the link into the chat if anyone's interested in having a look at the presentation from an asset management, from a pipeline intelligence perspective. I'll grab that and pop it into the chat. So no, it went really well. We had, gosh, it feels so long ago. What did we have? Nearly 200 people in person and 100 and something people online. So it was a good, successful day with lots of interaction and some fun to be had. So yeah, that was really it. But I'll pop that. I'll go in and pop that link in now, Christina.
Thanks. Hi, Dennis. How are you?
Very well. How are you guys doing?
Good. How are you?
Good. Good.
Was there anything, Dennis, from last working group meeting that you wanted to just recap on? Because I wasn't there. You may not remember because it was 4 months ago.
Yeah, it was. No, there was just a bit of follow-up and a question and answers that came from the audience. But yeah, no, I don't think that there was anything that was particularly that was carried on.
And the KeyTOS presentation and the notes are all on the Knowledge Hub as well. So I'll throw the link for the Knowledge Hub in here. And if there is anyone on the line that hasn't registered for the Knowledge Hub, it's really easy to register. So I'll put the registration details in as well. But if you're registered and go into the Pipeline Intelligence program, you'll be able to see that if you wanted to catch up on that presentation as well.
I thought I might just mention also from the IWN side of news. I'm not sure whether 4 months was that was the case, but Tas Water has joined us as one of the members of IWN. So this is our first member that's not within Victoria. So that's very exciting. So we're just looking forward to that trip to Tassie to visit them.
Wait.
Maybe in the summer.
Yes, definitely. Well, even in the summer, we'll be wearing like our turtlenecks that, so long as there's crayfish in season, who cares?
Exactly. Well, apparently it gets pretty warm these days in Tasmania in summer. So
yes.
Who knows?
Yeah, wow.
Now I'm happy to just roll into the presentation if everyone's happy with that. James?
Absolutely.
I might just most people got their cameras off, but we might turn our cameras off, James, so we don't lose you halfway through your presentation.
Sure.
Is that okay?
No problem at all. And just to check, I've got about 10 minutes. Is that right?
Yeah.
Yeah,
and then we've got, and if anyone's got any questions, you can either pop them on the chat. Are you happy for people to interrupt on the way as well, James?
Absolutely. Alyssa can vouch. We're not very formal people at Five Cents. We like to have a chat. So what I might just try and do is see if the internet gods are going to be nice to me and let me share my screen, because I do have a couple of slides just to give you guys some pictures to look at as we go.
That's great.
I've got the spinning wheel of death already, which is never a good sign. So let's see how we go. If those pop up, brilliant. And if they don't, that's also fine.
Well, if they don't, you can, if it helps, you can shoot over the presentation to me and I can put the presentation up for you.
Sure. That's kind of you.
That
I'll
helps.
what I'll do is I won't waste everyone's time now with worrying about that. I'll just chat through, and then any questions, jump in, and we'll send it around sort of afterwards via email, so that
Okay.
it's got them sort of handy. So, hello everyone. My name's James Stewart. I am job title is actually the Vice President of Strategy and Marketing for 5%, which sounds awfully grand. Which is to say that we're doing a lot of work with our friends in Asia who respected a good job title. I'm employee 17 at what I think is one of the most interesting and important deep tech companies to come out of Australia for a while. What we really do at our heart is we use fiber optic cables to act as a massive array of sensors, and we use those massive array of vibration sensors to detect threats to underground infrastructure, particularly water pipes, gas lines, telecoms cables, power lines. We have basically a parallel operation that works on our subsea cables, and we are now Series B funded. We're scaling up internationally. We've got a number of reference clients in Australia: Transgrid and Basslink, Southern Cross Cable. Would be sort of the best known. We're sort of in the press as working with Palmerston City Government up in the Northern Territory and with Vodafone in Wellington, New Zealand. And there, frankly, that's just the tip of the iceberg. We've got a lot of other clients who are using us basically to fulfill the issue of sensing in an urban environment. The way we work, we pulse a laser down fiber optic cable. Usually that's a telco line. In some cases, the utilities may themselves have their own cable that they have access to. Power companies often do, sometimes pipeline operators do. But generally, we're used to going off and doing a deal to gain access to telco fiber on behalf of clients. We then put a piece of hardware into a telco exchange or into a standard internet rack at any fiber access point. We pulse the laser down the fiber, and that laser has backscatter from the fiber optic cable itself. The little imperfections, just like in a nightclub, if you see a laser, you're actually seeing the backscatter from the laser off the smoke particles, and it's the same in fiber optic cable. There's a little tiny imperfections, so about 0.1% of the light comes back to the unit that fires the laser out, and it's that backscatter that we're looking for. From the timing of the pulse, we can see how far down the line something's occurred. And what it really boils down to is when you flex a fiber optic cable by a microscopic amount, it changes the nature of the light that's passing through it. And that's what we're really making use of. So each fiber sensor unit, in effect, is like putting 20 to 30,000 vibration sensors out. We cover about, we tell clients we have 2 ports on the unit, which does 2 separate optical paths. Each one about 50 kilometers. We actually get a fair bit more distance depending on the quality of the fiber, but in some countries the fiber quality is quite poor and we have high losses. But really we go for stretches of high pressure mains, really high consequence areas. Usually that means urban, where disruption is very, very pronounced if anything goes wrong. Our major activities are looking for excavators and jackhammers in particular, because those are the threats to the cable that are most likely to damage a pipe and all the cost that goes with it. The reason I get excited about the water industry in particular in this use case is a couple of fold. So firstly, we avoid the accidental damage to the pipes themselves. There's a beautiful graph which I'll send around, which is anonymized from one of our senior clients, where they were having basically an incident every week where they were having to send their field force out. They were patrolling around and they were finding something wrong every single week, month in, month out. They started to use FiberSense to queue their field force to where they go to, and we took them down from 1 a month to 1 every 2 weeks. And then we took them down from that to 1 every month, and now we've got them down since August last year. They've had no incidents where they've had to go to site. The reason that works is that we've closed the plan, do, check, act cycle. So now if you're a contractor and you go out and you start excavating and you haven't filed your die before you dig plans, we will detect it instantaneously anywhere along that section that we're protecting. We monitor away from the asset, that they don't have to be smack bang above the fiber. The vibrations travel through the ground. So it's very normal for us to use telco fiber on one side of the street to monitor pipes on the other side of the street. We'll pick up the excavator or the jackhammer very easily. And so now if they cut corners to try and speed things up, someone will show up at the site and talk to them and say, hey, you're doing the wrong thing and you're threatening our pipes. Do you know what's down here? All this kind of stuff. That has consistently changed behavior. And so the customer is delighted, and we're just waiting for approval for that to become a full public case study that we can share with people. But at the moment, the anonymized graph is pretty striking. So I'll email that around after this call. The second use case that we're really after is the high pressure water mains. So those bursts have a distinctive vibration signature. All vibration sources are pretty much identifiable by our software, because they have specific frequencies that we've trained the system to recognize and look for. We are in the process with some of our alpha clients, excuse me, in Spain and the UK in particular, of training that burst water main detector to be automatic. But in a sense, it goes off, it vibrates the ground, we detect it within seconds, we can alert the water company immediately, and they can get out there to either shut the water off or start making emergency repairs. We are working and moving towards slow leak detections, which is more to do with saturation of the ground over time, and that is more of a predictive maintenance type product. So it's in development, but it's not on market as yet. The reason this matters so much, as I think the folks on this call would understand, is at the moment, water companies run with a certain lost water rate. And that water rate is costing them money in some countries, depending on how they're regulated and how they pay for water in the first place. But fundamentally, they basically budget a certain amount of money for emergency repairs at the moment. And we are trying to help people understand that they can fundamentally shift from an emergency repair mindset across to a preventative maintenance mindset. And that means getting rid of emergency scrambles in the dead of night to try and repair things where someone's hit a pipe or it's gone wrong unexpectedly. The savings therefore are double counted, if that makes sense. So the clients are saving on the on the emergency repair work itself, and they're able to redeploy that labor in an efficient way into maintaining their network more efficiently, which of course has lower cost, and therefore they save the water that they would have lost through the strike and the water they would have lost if they hadn't had the chance to go and do those preventative maintenance activities. So at the moment, things are looking really good. We're scaling up. We're in conversation with IWN. Frankly, we're just waiting on our fiber partners to sort themselves out and to donate the fiber into the trial. We will be switching on the network as soon as we can in the Melbourne metropolitan area. For those who perhaps have had an oil and gas background, fiber sensing is a fairly well-established technology in oil and gas industry. They use it to monitor boreholes going down into the ground, and they use it to monitor pipelines through deserts and things. The key here is that those technologies, although they're very well established, they don't work well in urban areas. So there's lots of vibration, there's trams, there's all sorts of things. Not everything, of course, is a threat to an underground asset. And so it's very important to us to make sure we have a really good false negative, false positive performance, which is outstanding. If we didn't have that, and if our AI wasn't able to screen out false negatives and false positives, we would have basically customers getting far too many alerts, and that wouldn't do. So we really cracked that a couple of years ago, and as a result, our clients really know that if they get an alert, it is a serious event and they need to get to site immediately. And it works well. I can see a couple of questions coming in, so I'll pause there and just take the questions.
Thanks, James. I popped my hand up because I wasn't sure if you'd seen them. Alex has sent through a question. Do bursts need to be of a particular size scale to be picked up, such as, large perforation, or could slower, smaller leaks be identified as well?
That is a very astute question, frankly. So the answer is yes, they need to be a certain size. So what we're telling people at the moment is we look for and reliably find anything above 4 liters a second, which is quite big, as you will all know. That is a burst main, and probably quite a big one. The truth is that actually it's down to the level of mechanical energy being put into the ground by the burst or by the leak. So at the moment, we are doing the work to refine our detectors more and more and more, which is taking us to a smaller and smaller leak size. But there's a little bit of a trade-off because the energy dissipates as the vibration energy as you go further away. There's a little bit to do with the soil mechanics in particular. There's a little bit to be done with the pipe materials. So some of the things like steel pipes and concrete pipes are slightly better than, say, plastic pipes. They vibrate a bit more enthusiastically. So we tend to get a better transmission. And then, of course, there's the distance between the pipe and the fiber. So for burst mains in particular, we try to be within a few meters of the pipe if possible. And sometimes with some clients, we have to say, look, we'll do asset protection across the whole network, and wherever we've got fibre in the same road, that's no problem. But for burst water main, we'll only be able to cover certain stretches until we either infill with new fibre or we gain access to another fibre network that gives us that little piece of coverage. The point about slow leaks in particular, it's quite a different mechanism. So small, slow leaks, very low kinetic energy. It's more to do with the saturation of the ground, and the saturation of the ground changes the acoustics of the ground, or changes the vibration profile of the ground. And so we can absolutely detect that. It's just a case of training it from, do we have the physics and the understanding of the ability to do so? Yes, absolutely. Do we have a detector that we're happy to put in front of clients yet, where it will run automatically and tell you that the leak is going off? Not yet. So it's coming, and it's a huge, huge issue for all of our water clients. And so it's very much top of their list, and we're working with them. The main ones in particular that, again, we can't announce yet, but there's a couple of very big water companies in the UK and in Europe who are actively working with us as our development partner to bring that to a maturity level that will release it to anyone.
Thanks, James. I'm just going to go in order of the questions coming through. Dennis had a question. Is there a timeline for the rollout of the slow leak detection? I'm not sure if you've answered that one already.
There is a timeline, but we're not committing to it yet because we want to see how fast. It's a bit of a technical question. Training the algorithms is a little bit of a tricky thing to say, oh, it's coming in a certain amount of time, but I would suggest 12 months or so. Because the company is an engineering-led company, and we're very particular about our commitments to customers. So if we say that we're going to have a working detector, it's got to have 4 or 5 nines, false negative and false positive performance at least before we'll be happy to put it out to general release. With a research client or someone who's actually actively working with us to develop that slow leak detector, then fine, they understand it'll be a best endeavors until we get that training level up. So I don't think we're looking at it for the next year or so, but feel free to get in touch and we'll keep you posted. At the very least, I'll add you to our water mailing list and we'll keep you posted as we go. One of the other ones that has come up is water hammering, which we know is a big issue for certain networks in certain countries, and it's a classic use case for a vibration-based approach, which is what we are. And we absolutely can do water hammering. It's just a case of having a client who says, hey, this is a huge problem. We want this now. And we will work with them as our primary client to speed up the training of the algorithms, basically. Otherwise, it's going to be a case of, as we accumulate detections of water hammering on the citywide networks, we'll be training the detector.
Awesome. So the next question is, how do you rule out false positives for underground pipes in similar areas?
So the false positive performance is important. Clearly, a false negative is more damaging than a false negative, than a false positive. Sorry. So basically saying there is no problem when actually there's a threat to a pipe is a huge issue. And so we really focus on the false negatives in particular. False positives, they're bad, but they're not as bad because what it results in is effectively a false alarm where the field force go out and look for something and then realize it's not there. It's a case of training up the algorithms to make sure that performance is good enough. That's why I'm really trying to labor the point that we won't release something to a client until we've got that false positive performance down to 1 in 10,000 type levels. Because if you've got a field force and you're telling them scramble to get to stop an excavator or scramble, there's a burst water main, there's only a certain number of times that they'll do that before they say, well, actually, we don't trust this. And it's really only once or twice that you can use that goodwill. So we take that as a very, very important point for how we develop products. As I said, we have a slightly different view if we're working with a lead client in a particular new detector, then as long as they understand that it's going to be best efforts, but we wouldn't really go live with something if it wasn't up to scratch, even in that research arm version of it. Does that answer the question?
Does that answer the question for you, Scott?
Not quite. I wasn't exactly sure how you sort of indicate. I was more interested in the technical side, I suppose, rather than the, because it does, like, we've got like a lot of area to cover and we don't have many resources to cover it a lot of the time. So if we're going out to different areas and then we get called out to something that's nothing and then something else happens and we're behind on that, then that becomes obviously a big problem as well. So I just wanted to understand how it sort of knows, like if you got pipes in similar areas, like if you got gas, like, because sometimes we'll have gas like 300 or 600 away from our sewer pipes or water pipes, and it's like, well, how can it differentiate between like,
so that's a great one, Scott. So a couple of points probably just to emphasize. One is, I didn't really say it, but the point here is that one fiber sense unit, one telco exchange can cover a significant fraction of the city. So this is not like putting sensors out in the field IoT stuff. And I forgot to mention that. So thank you for the prompt on that. So to cover a city the size of, say, Melbourne, we're really looking at, depending on the network configuration, 4 or 5 pieces of hardware going in. And then we never sell equipment. We always run it as a managed service so that everywhere in the world, we're feeding the information into the algorithm. We're trying to get it better and better and better and better for everybody. And that's important because running this equipment is really very technically tricky and we need sonar technicians and things like that. So there's that one. Your point around pipes for what we call digital assets. So for preventing strikes on pipes, it's the same, if that makes sense. So if there's a threat on the street, usually the clients will say to us, if it's on the street, we want to know. We've got a client who really only wants to know if the threat is within 2 meters of their cable. And so we've changed the sensitivity on the detectors just for them, or in the software, I should say, sorry, just for them. That's pretty unusual, but that was their choice and that's okay. For things like burst main versus gas burst, the kinetic energy behind them is generally very, very, very different. So burst water mains, of course, show up much more strongly than a burst gas main. Frankly, if we had a burst gas main detector trained at this point, we would be basically running on every single gas network globally. So it's coming. The Americans are very hot on that topic in particular, and they have had, unfortunately, accidents where people have had incidents, but we haven't yet had an issue where we've struggled to identify a burst water main versus a burst gas main. It hasn't occurred because the vibration signatures would be very distinctly different. So the frequencies at which they would be pounding the ground is really what we're after. And there's a fingerprint to a different type of issue or a different type of threat. It's not just the intensity of a vibration, it is also the frequency modes inside there and the transformers that we do on that to then identify what it is. So it's not, that's actually a very sophisticated point that a lot of folks don't get to, is that this is not just oh, there's a vibration source. That's good enough to know that you should go and investigate. It is also the identification and classification of the vibration source. So what we really run at the moment, for Chatham House rules, is we run a number of very highly tuned and highly trained detectors for certain types of threats that the clients are very interested in. So jackhammers and excavators in particular are very crucial because they can damage assets and cause an incident. And that's our primary bread and butter day in, day out, operating in multiple cities worldwide. And then there are other detectors for things like burst water mains, which are in development with our primary clients, where we are working with them as we identify one or as we simulate one for them. Then we are able to refine and improve the ability to detect that fingerprint more and more and more. And then as we go to things like slow leaks with saturation around the ground, that is a slower process because we need a longer accumulated data set to train the algorithm. But in all cases, there is a characteristic frequency fingerprint for each of them, and it's that identification piece that lets us, to your point about false alarms, that's part of why we're so good for false alarms. Yeah, because we know what it is, not just that there's something there. We do run what we call an anomaly detector, which is just not only do we have our operations center that people look at the waterfalls in real time, but there's an anomaly detector. If we get an intensity and we don't know what it is, that will trigger automatic recording. That'll be classified and investigated by our team to start to build some sense of pattern around what is that. And the anomaly detector has thrown up some very interesting things around condition of assets. So, for instance, we had an example where we had a cable running across a bridge. It was across a small bridge here in Sydney in the north, and a panel broke free in high winds and was banging, basically. And that showed up as an intermittent weird signal, triggered the anomaly detector, and the folks investigated. And basically, we phoned up the client and said, look, we're seeing something strange on your network. We don't know what it is. We know what it isn't. So we know it's not an excavator. We know it's not a jackhammer. We know it's not a burst. You know, we think there's something going on. Do you want to know? Do you want to go have a look? And in some clients, they absolutely do want to know, and others, they're not so worried. So the subsea cable folks, they pretty much know what the threats are to their cables. And if it's not one of those, they're not so fast. But for utilities operating in cities, they generally have a field force that is around in the area, and they do want to know, and they want to go check it out. And so we've had some sort of what are currently one-offs where things like panels breaking free in high winds. It's interesting, but it's not that common. But going forwards, those will become sort of standard pieces of software that we just run on the network anyway, and we can tell people what they are, and therefore we can help them understand a little better. We think it's a panel breaking free on a bridge. You should probably go have a look.
Yeah,
so
that sounds good. Thank you.
Sure. Any more, Alyssa? There's in that case, there's just one more that I wanted to make sure. I moved sideways as I tried to look at the questions. There's one more thing just to mention, which gets me a bit excited. Others are not as motivated by it, but it's the climate change angle in particular, especially with the UK going through what is now quite a severe drought and very high temperatures. This has gone way up the list. Not just for the climate change, but also for the water scarcity point of view. So I appreciate, and I think the folks on this call understand, that people digging into pipes for water companies it does happen, but it isn't the primary driver. We know that. It is an expensive problem, and generally when we go through water companies' reports with them to understand strike frequency and repair costs, etc., it's enough that there's a good business case for them, and they should generally take it seriously and put it forward. Even without burst water mains, which of course are also quite rare. They do happen, but they're high consequence when they do. And then what we're working towards is the leak detection. But that said, in certain operating environments, we're getting a lot of interest in really ruling out and eliminating third-party strikes from a couple of points of view. One, being seen to be actively reducing leaks, being seen to be actually taking effective action on chopping out the roughly 10% of lost water that's attributed to third-party action. It's important at the moment that people are being seen to be doing things, and that it's real, and that it's having an effect on their water loss numbers, as well as their direct bottom line in terms of operating costs. The other one is that, and before I joined Fibersense, I had no idea that the emissions, the carbon emissions that are attributed to lost water worldwide is really high. It is something like 1 to 2% of all human carbon emissions, depending on where the electricity is derived from. If you're in a coal-burning country or state and you're losing water at the rate of 20 to 30% or 20%, let's say, of the water that goes in, which is not uncommon in Europe and North America, that is an enormous amount of energy that's being wasted and cost that's being wasted. And so we have a technology that at city scale can cost effectively start to chop out some of those costs for real and chop out some of the emissions. So at the moment, people are coming to us for the reasons of network resilience, infrastructure, monitoring and awareness. Yes, they want the bottom line cost improvements for their water company, and that's good. We're also starting to get interest from people because of the regulatory pressure to be cutting leaks in a material way at network scale. We're out and about with a turnkey solution that can do a very large part of the city pretty much immediately. Without having to go out and put thousands of IoT sensors into the field. That's the key difference. So it's something that motivates me very strongly. If folks are interested to discuss that further, I'd be very happy to talk to you about that. And as I said, Alyssa has heard from me on many occasions that as a new Australian, I really want to see Fibersense running in every single city, protecting all underground utilities and assets. Today has just been about water, but this is exactly the same set of issues that face the power company, that face the gas company, that face the telcos, and the University of Birmingham has a pretty confronting study that I'm very happy to share with everyone that is the true cost to a city of repairs to underground utilities is something like 29 times the direct cost of the repair itself. That certainly has kind of caused a wake-up call for some of our telco friends who have been very blasé because if fibre cut, they might have redundancy, they might be able to reroute, but they're not normally very worried. And as we've seen with the strike that happened in Victoria and in Tasmania and took Tasmania off air for 6 hours, the costs of infrastructure outages are really very high, and the folks on this call really do understand that. But the cost of actually protecting them has been also very high historically, because putting out cameras and hydrophones and things like that, high accuracy, very limited coverage of the network. And so really we're coming at it from quite a different point of view, that we work with those existing point solutions, but we really try and go for the entire city, the entire network, and we really try and eliminate these incidents before they ever actually occur or very quickly after. So the power company folks absolutely love it, because if they ever do get a short circuit, we pinpoint it down to the nearest 3 to 5 meters, and we can tell them instantly, basically, and they can have someone out there. So their outage numbers are improving considerably. When those do occur, the pinpointing is worth it in itself. We're finding a similar conversation with some of our water company customers around pinpointing burst mains. When they do go off, it's not so much about the size of the leak, it's just knowing where to go instantly and to within a 5-meter section rather than 400 meters of road to try and find where the problem is. That's the key. I'll pause there and draw breath. You can tell I get quite excited about the technology, can't you?
I think we have a few other questions. Elisa, you're on mute.
Oh, I'm so sorry.
That's okay. Elisa, you on mute?
Sorry. Thank you. I think that you've answered everything. There's just one here from you, Dennis. Did you want to ask the one around the cost of deploying the system?
Sure. I'm not sure, James, if you're allowed to discuss these matters in a forum like this, but just wanted to get an idea of the cost of deploying a standalone system, because we are a regional utility and oftentimes our raw water mains and some long mains don't have they don't necessarily run parallel to the road or a road reserve, so they won't have any fiber optics running past them. But is there an indicative cost that we can get if we decided to deploy the system ourselves? What sort of cost would we be looking at?
Sure. So there's a little bit in that, and by all means, Dennis, give me a call. I'm happy to just chat you through in a little bit more detail. Generally, once we start to look at people's KMZs or their network map, we can start to give them a much better feel for things, and we can go off and try and find the right fiber partner to match. If we can use existing fiber, that's the key, is that by reusing existing fiber, there's zero cost to put the sensors out, as it were. There's just the unit at the exchange. In Palmerston in particular, we have actually laid fiber for the council. So we've helped them basically to go find a contractor, and we've put the fiber in as part of the service. So we can do it. That's not usually very exciting for people unless they have very high criticality piece. So it's possible, and if it helps a lot, absolutely. Some of the gas folks are talking about laying fiber specifically so they can monitor the pipe networks and the intercity trunk networks in particular, because they're just so critical that if there's ever an issue, they need to know immediately and intervene. The thing I'm getting around is we generally tell people a few thousand per month per 50-kilometer stretch, and that's usually not including the fiber. So if it's somewhere urban, dense with existing fiber and we can access it, then that's usually a more fruitful sort of opportunity for people. So any of the major capital cities, there's a lot of fiber out there. I will say that some telcos are a bit friendlier and a bit more hungry to help, and they really take this as part of their mission. We have had to teach them new ways of thinking about their network. It's not just about providing internet services. It is actually about the true IoT sensorization of the city, which they all talk about. So depending on where the network is that you're interested in, we often have friends in the telco industry who can give us fiber access quotes quite quickly and quite cheaply. Other times it's a bit more drawn out. So the case in Melbourne has turned out to be quite drawn out because of where that network was picked to be. I think in hindsight, Alyssa and I might have chosen somewhere else and done it a little differently, but we're almost there. And it gets easier every time we do another one. It gets easier. So, the key insight here is that we do tend to price as a monthly fee as opposed to selling equipment or anything else. So it's all done as a turnkey.
Yeah.
And the slides I'll send around will give you some screenshots of what that portal looks like. Most of our customers just look at the portal on day one and they're interested to see it in real time, and they never look at it again because they're just watching for the notifications of where to go to. So we do not to knock, or we can do knock to field force as the clients wish. But most of them just want to know where they need to go, what they need to do as fast as possible. And they're very welcome to go into the client portal, but they tend to not after a certain amount of time. You know, it's novel for the first few months, and after that, it's part of how they run. So we just provide it for a monthly fee, and we do it on a per 50-kilometer stretch basis. If we find we have very good fiber quality, we can do a little bit longer distance, but usually 50 kilometers in Australia is about right.
All right. Yeah. Cool. That works. And can I also ask if it's less than 50? Is it on a pro rata basis or?
Unfortunately, not, sadly, because it's a per box basis.
Okay. Yeah. Oh, all right.
So yeah, doing 50 versus 60, it doesn't matter. The software will run, but we generally will do 2 paths per box, and that's generally enough. So to put it in context, that would give you 100 kilometers of network coverage. So depending on, most people will start with high pressure, high consequence places where secondary damage from undermining of the road surface or buildings would be very, very expensive or difficult to fix. And they'll normally start with those high consequence areas first. And frankly, we tell people, send us where you're getting the most threats to the pipes. Send us to the high construction areas where lots of traffic, you know, where it's really vibrating a lot. There's a lot of activity going on where you're going to get the most benefit. So we normally go for those first. And then sort of things like suburban gardens where, yes, it's bad to get a leak, but it's less pressing and you have more access and less secondary damage. We'll get to those when the use case is sort of proven and everyone's happy, and we go for full network, which is sort of where we're getting to with some of the UK cities now.
No worries. Understood. Thank you.
I think that was it from a question perspective. So thanks, James.
My pleasure.
Did you have anything else to add here, Christina, or can we let James off the hook to get some time back in his day?
Maybe that report that you mentioned, James, would you share that with us from the University of Birmingham?
Yeah, no problem.
Yep. Thank you.
It's quite a confronting number when you realise that. I mean, this is the other thing, that the true costs of utilities, I think people have suddenly got them back on their radar, and because of the cost of living squeeze and with inflation coming through. And here we are with a technology that can genuinely start to chop out the costs of service, which is really positive. And so, you know, we really need to go for this because people are stretched. If you take out the 10% of lost water that's associated with strikes on pipes and the sewage network and the stormwater network, and this is all real dollars that turn up in people's water bills and in their taxes. Yeah, we're really on the warpath to try and prevent that in the first place. So anyone and everyone who's interested and is an ally in that, count me in and give me a call. Always happy to help.
Fantastic. Thank you. So I've got a few things. You're going to send through the presentation notes, the slide pack and the report, and I can attach those to the minutes.
Yep.
And then we'll have this video as well. Awesome. Thank you so much, James.
My pleasure.
No doubt we'll be speaking to you soon.
I'll look forward to it. Take care, and I'll see you in Melbourne soon, Alyssa.
Ciao. Bye.
Bye.
Yeah, thanks, guys.
Bye.
So now what I'll do just quickly, just to go through the current trials, and some of them have the trial may have wrapped up in within one authority, but there's another one pending with another authority. So I might just cover what's the current and what's coming next in one go, as per the agenda. So sorry, of course it gets really noisy in the office when it's time for me to speak.
It's all right. We can't hear it.
No, you can't hear it. Okay, that's good.
It's all good.
Okay, so a little bit of an update maybe from the Telstra modular trial. Dennis, would you like, because that's the one within where you are. Sorry to put you on the spot. You're probably the best one to give us an update on the Telstra modular trial. Are you on mute, Elisa? Or did we
It
lose
looks like
Dennis?
Oh yeah, we've lost Dennis.
Okay. So the trial at Barwon Water finished, and the trial is now at Northeast Water, where Dennis works. So it's basically, if anyone's not familiar with the Telstra modular device, it's a gas monitor that gets put into the sewer manholes, and it detects a variety of parameters like temperature, H2S. It gives us a lot of really good information real time. So that's at Northeast Water now. Now there's another, the NodeDes trial, which is mains flushing technology, where a truck sort of creates a closed circuit for main flushing, so there's no water wastage, and it treats the water and puts it back into the water main, which is pretty cool technology from the US. So the trial finished at Gippsland Water. It was a successful trial. We're waiting on the report on that, and we've had a few inquiries actually about the report and the outcomes of that. And there's actually we have interest from a few other authorities to trial that as well. So that's coming up. PipeScan, which is a water quality real-time monitoring device, that's trial to commence at Barwon Water shortly. I think they're just waiting on some equipment. That one can actually detect up to 10 parameters in the potable water live environment, but in terms of the trial, you can pick and choose how many different parameters you can you want to monitor, so you don't have to get the whole lot. And the last one is the real-time network monitoring Verge solutions. That's also a water quality monitoring trial. So sometimes what we do, we run a couple of trials that are very similar in terms of the outcome that produce, and then we compare them, and not for any other way than just to see the differences, I guess, in how they operate and whether both are actually suitable, or whether one can learn from the other. So all that information is available to everyone to see and to share. And any of these trials that we're talking about, the reports, once they're available, they are on the Knowledge Hub. Is that correct, Lisa?
Yeah. And if anyone's got any specific questions, I was just taking notes while Christina was talking. Just shoot through, questions either to myself directly, or I'll pop the inquiries email in here as well. With the NodeDes mains flushing, we've also got a really good video that summarises how that works. So we did that video when it was being trialled at Gippsland Water. So if there is anyone on the call that's interested in that one, we do have a good video on that. And I suppose the only other comment I'd say around the Verge Solutions one is that trial has only just commenced. Like, we literally just put that particular unit in, July. And that's at Greater Western Water. So, but yes, if anyone is interested in getting extra information, it is definitely on the Knowledge Hub as we get it. But if there's any specific information that you want, just either shoot myself an email, or I'll pop the inquiries email in here as well. So either or is fine, because I answer both.
Okay, I'm happy. Yeah, I'm happy to go to general business if anyone wishes. So I guess here, if anyone wants to have any questions or give us suggestions on anything, any technology, or an issue that they have within their authorities that they would like us to sort of look for a technology and a solution. And that you can send that through anytime. It doesn't have to be during these meetings, but just let us know. And because we have contacts with a variety of suppliers, not just within, not just nationally, but worldwide. So internationally, there's a lot of things happening. That very exciting things happening that we probably not hear about until later. So definitely happy to hear about any needs or any issues that you're having within your authorities.
So on that note, is there anything that anyone on the call needs us to follow up on?
I've got one, Elisa and Christina. Sorry, I'm probably only relatively new to this forum. And I know that previously, I think I've seen some information on like non-invasive condition assessment technologies like PCAT. I was wondering if there's anything else that's been happening in that space of late and whether there was anything else around maybe that might be worth looking into. Sorry, it's Alex from Yarra Valley Water.
Yes,
Thanks,
thanks, Alex. It's a good question. It seems like the PCAT is the one that we keep referring back to because it was fairly successful and not too expensive. Anything else that's on the market, it's fairly more expensive, but not a lot at the moment. And it really depends on the type of pipe that you're also looking at, and also whether it's water, sewer. When I say sewer, I mean rising main. So it really depends. It seems to be mostly concentrated on water, sort of pipe work, but we can definitely sort of cast in it and have a look what's, because we've been getting quite a few inquiries about non-invasive condition assessment because it's so expensive to do.
Yeah, I think that'd be good. I mean, for us, it's mostly in the water space, but yeah, metallic pipelines. We've probably got a few other materials, but metallic would be the main percentage of the cohort. Yeah,
that's an action.
I've just written that down as an action to reach out to the network to potentially identify some other opportunities in that space.
Hi, I want to add something. I'm Sophie from Greater Western Water. I'm currently working on a contract with PCAT, which is Detection Services Technology. It was the project that our Croatian engineer Candice identified. We are going to trial PCAT and EPOS technology for condition assessment of the metallic pipes. She has chosen a number of large size of like mild steel or cast iron pipes. We want to know the condition of those pipes and for us to make decisions for the future risk assessment or risk renews, and in terms of the investment of timing and the cost, etc. So we are willing to trial these two technologies, and we got the business case approved by our MD. So we're currently working on these two contracts to get those two technologies trialed in the Greater Western Water. So
what's the second one, Sophie? PCAT and
EPOS.
EPOS.
EPULSE.
EPOS. Okay.
EPOS. Yeah.
Yep.
Yeah.
So that's for metallic pipes, yeah?
Yeah. Mainly large size of metallic pipes, so like 375 above. So yeah, we've identified a number of pipes to be trialed using those two technologies. Yeah.
And would you be happy to share that information with the group when you get your results?
Yes, definitely. When we get the results or outcome, you know, when the trial is completed, I'm happy to share back with the group. Yeah.
Cool. Yeah, it'd be good to stay in touch, Sophie, because I actually spoke to Candice a while ago about about some of that stuff, because I was interested in what EPOS could do and how that compared. But
yeah, no problem.
Nice one.
Yeah, I'm just taking over the management of contract because she's on us in comment. So
okay.
Yeah.
Cool.
Well, that's awesome. Thank you. And then we'll reach out and see if there's anything else on the market. Anyone else? Scott? Richard?
I'm good for now. Thank you, though.
Okay.
We got a few good actions out of today.
Yeah.
So that's great. Awesome.
All right. Thank you all for attending.
Thanks, everyone.
Thank you.
Make sure if you need any info, just reach out anytime. That's great.
Mhm.
Thanks, Christina.
Thank
I
you,
guess I'll
guys.
see you tomorrow.
See you tomorrow.
See you,
you all.
everyone.
Bye.
Thanks,
Bye.
everyone.
Thanks, guys.
Bye.
Bye,
Bye.
everyone. Bye.